You're standing at the edge of the asphalt at Road Atlanta, the smell of unburnt race gas stinging your nostrils, watching a grid of million-dollar machinery warm up. You see the sleek silhouettes of modern Corvettes, the aggressive aero of factory-backed Vipers, and the precision-engineered German iron that costs more than your house. The air is thick with the sound of high-revving, computer-controlled perfection. But then you hear it. A deep, guttural rumble that doesn't sound like a sewing machine on steroids. It sounds like a thunderstorm trapped in a cast-iron box. It's distinct, it's heavy, and frankly, it sounds a little bit angry. The light goes green, and what happens next defies every law of modern automotive economics. That rumble doesn't just keep up, it starts hunting. By turn 3, the expensive carbon fiber wonders are getting a view of taillights attached to a chassis that looks like it belongs in a museum, powered by an engine that belongs in a dump truck. This is legacy motoring. And I spend way too much time thinking about how forgotten iron is embarrassing modern tech. If you're someone who believes that engineering peaked when slide rules were still on desks, make sure to hit the subscribe button and give this video a thumbs up if this helps you out. Here's the thing. We live in an era where we are constantly told that newer is better. We're sold on the idea that complex variable valve timing, direct injection, and hybrid assists are the only way to go fast. We look at spec sheets that read like computer code and nod our heads, assuming that the billions of dollars spent by OEMs on R&D must mean they've reached a pinnacle of performance. But what if I told you that the smartest guys in the room aren't the ones with the PhDs in fluid dynamics working at Ford or GM today? What if I told you the smartest guys are covered in grease, working out of cinder block shops in towns you've never heard of, using an engine design that was literally thrown in the trash 40 years ago? We are talking about a specific piece of cast iron that was designed during the Nixon administration, killed off before the internet existed, and is now, right now, in 2026, beating factory teams that have budgets larger than the GDP of a small island nation. This isn't just a story about horsepower. It's a story about arrogance versus experience. It's about how the automotive industry got so obsessed with efficiency and emissions that they forgot how to build things that just don't break. And the hero of our story? It's not a Ferrari V12 or a exotic SEMI. It's a truck engine, a boat anchor, the Ford 385 series, better known to you and me as the 460. Now, you might be thinking, come on, a 460? That heavy, smog-choked lump from the 70s Lincolns? And I get it. If you grew up in the 80s or 90s, your memory of this engine is probably a wheezing 200 horsepower disappointment hauling a Winnebago up a grade at 45 miles per hour, getting single-digit fuel economy. But here's what most people don't realize. That disappointment wasn't the engine's fault. It was the government's fault. The architecture itself, the bones of the thing, was hidden under a suffocating blanket of emissions equipment and detuned timing. What the small shops discovered decades later was that if you stripped away the politics, you were left with a masterpiece of mechanical violence. To really understand why this is happening, we have to go back to 1968. The vibe in Dearborn, Michigan was tense. Ford was getting kicked around on the track. Chrysler had the 426 Hemi, which was basically a race engine sold to the public. GM had the big block Chevy, which was cheap and effective. Ford's existing big blocks, the FE series, were great, but they were getting old, complicated to cast, and expensive to machine. They needed a clean sheep. They needed a weapon. The mandate from the top was simple, but impossible. Build us an engine that is lighter than a Chevy 454, stronger than a Hemi, and can be mass-produced cheaply enough to put in a station wagon. Enter Bill Gay and his team of engineers. These guys didn't have CAD software. They didn't have finite element analysis to tell them exactly where a block would crack. So they did what any sensible engineer with a slide rule would do. They guessed. And then they doubled it. They over-engineered the absolute living daylights out of the bottom end. They looked at the main bearing caps, the parts that hold the spinning crankshaft in the engine, and decided they shouldn't just be caps. They should be bridge girders. They designed a block with a skirt that extended past the center line of the crank, adding massive rigidity. But the real magic, and this is where it gets really interesting, was in the dimensions they chose. See, an engine is basically an air pump. The more air you can move, the more power you make. but the physical size of the engine block dictates how big that pump can eventually get. Most engines run out of room. The cylinder walls get too thin, or the deck height, the distance from the crank to the head, is too short to fit a long stroke. Ford's engineers, for reasons nobody fully understood at the time, gave the 460 a bore spacing of 4.900 inches. To put that in perspective, a big block Chevy is 4.840. A modern LS is 4.400. That difference sounds tiny, right? It's fractions of an inch. But in the world of engine building, that extra space is like discovering an extra bedroom in your house that you didn't know you had. It meant that 40 years later, engine builders could bore these cylinders out to sizes that make other engines look like toys, and there was still enough metal left to hold back the explosion of a supernova. So Ford builds this tank. They release it. It dominates absolutely nothing. Why? Because the timing was tragic. It launched right as the insurance company started cracking down on muscle cars, and then the oil crisis hit. The 460 was born to run, but it was forced to walk. It spent its life pushing heavy trucks and luxury barges. Ford eventually stopped putting it in cars in 1978 and killed it entirely in the late 90s. They moved on to the modular engines, the 4.6-liter and 5.4-liter overhead cam motors. These new engines were marvels of technology. They were smooth, efficient, and clean. But they had a problem. They were physically huge on the outside, yet tiny on the inside. A 4.6-liter mod motor is actually wider than a 460 big block, yet it has half the displacement. Think about that. It's like buying a mansion and finding out the interior is just a studio apartment because the walls are 10 feet thick with wiring and plumbing. While Ford was high-fiving themselves over their new overhead cam tech, the 460s were piling up in junkyards. They were worthless, scrap metal. You could pick up a running one for $100. And this is where the David of our story enters the picture. Small, independent engine shops, guys who were hurting during the recession, started looking at these piles of rusty iron and asking, what if? One of these guys was a legend named John Koss. Now, Koss isn't just a mechanic. The man is an engine whisperer. He's won the Engine Masters Challenge more times than I can count. He looked at a 460 head, a stock smog-era head that everyone said was garbage, and he saw something different. He saw a port design that was lazy, sure, but the shape was right. It was a canted valve design, meaning the valves opened at angles towards the center of the cylinder, unshrouding themselves for better airflow. This is complex geometry that Chevy only used on their most expensive race stuff, but Ford put it on dump trucks. Koss realized that if you just cleaned up the casting flaws and let the engine breathe, the numbers didn't make sense. They were too good. He found that a stock block pulled from a rotting Lincoln Continental could handle 800 horsepower without blinking. No aftermarket girdle, no fancy alloys, just stock Ford iron. Do you know how much money you have to spend on a modern Coyote engine to make the block reliable at 800 horsepower in a road race application? You're talking thousands in sleeving and bracing. The 460 did it because some guy in 1968 decided to make the cylinder walls a quarter inch thick just to be safe. But the industry didn't catch on immediately. It took a few crazy privateers to actually put these things on a track against modern cars to prove the point. Picture the scene. It's a NASA American iron race. You've got guys with $150,000 budgets running factory-sealed crate engines that are optimized by teams of engineers. They have traction control, ABS, and data acquisition systems that track suspension travel in millimeters. Then, rolling off a trailer comes a 1995 Mustang with faded paint and a hood scoop that looks like it was cut with a jigsaw. Under the hood is a 460 that the owner built in his garage over the winter. The factory teams are laughing. They're making jokes about boat anchors and front heavy handling. Then the qualifying times come in, and the laughter stops. Dead. The laughter stopped because the stopwatch doesn't care about your budget or your glossy brochure. It only cares about physics. And the physics of a 40-year-old pushrod engine were doing something that modern engineering said shouldn't be possible. But to understand how they were doing it, we need to get our hands dirty and look at the metal. This is where the story shifts from a history lesson to a masterclass in unintentional brilliance. See, modern engines are designed by committees who are terrified of one thing: warranty claims. They build engines with tight tolerances because tight tolerances mean less noise, less oil consumption, and happier customers who don't want their Lexus to vibrate. But tight tolerances are the enemy of high-performance endurance. When you run an engine hard, I'm talking 7,000 RPM for 40 minutes straight on a road course, metal expands. Things get hot. Things distort. In a modern engine with clearances tight enough to hold water, that expansion leads to friction, and friction leads to catastrophic failure. Ford's engineers in 1968, however, weren't worried about NVH, noise, vibration, and harshness. They were building an engine that might end up in a jet boat doing 60 miles per hour across a choppy lake, skipping out of the water and revving to the moon, then slamming back down under full load. They built the 460 with what we call sloppy tolerances by today's standards. But here's the secret. Sloppy is just another word for safe. Let's look at the oiling system. This is the heartbeat of any engine. If you open up a modern Ford Coyote V8, and don't get me wrong, it's a technological marvel. It looks like a maze designed by a madman. You've got variable displacement oil pumps, hydraulic chain tensioners, cam phasers that need specific oil pressure to adjust timing, and literally dozens of tiny oil galleries feeding the overhead cams. It's complex, it's efficient, and on a racetrack, it's a ticking time bomb. If you starve one of those cam phasers of oil for a split second in a high G corner, the computer panics, the timing goes off, and you might just send a valve through a piston. Now look at the 460. It uses something called priority main oiling. It's elegantly stupid. The oil comes out of the pump, goes to the filter, and then bam, straight to the main bearings. The crankshaft gets fed first. The rods get fed next. The valve train upstairs, it gets whatever's left over. And that's exactly how you want it in a race engine. Who cares if a rocker arm gets a little less oil for a second? It'll survive. But if your main bearings go dry, you're done. Ford designed the system so the engine could survive idling in traffic for hours or running wide open in a marine environment. They accidentally built the perfect road racing oiling system and they didn't even know it. And then there's the cooling. This is my favorite part. The 460 has water passages that you could practically stick your finger through. Why? Because it was designed to sit in a Lincoln Continental in Phoenix, Arizona, in August, blasting the AC while stuck in gridlock. It had to shed massive amounts of heat with zero airflow. Fast forward to a racetrack where you have 100-mile-per-hour wind hitting the radiator, those massive water jackets mean the engine runs ice cold. While the modern Corvettes are going into limp mode because their compact, aerodynamically efficient cooling systems can't keep up, the 460 is sitting there at 180 degrees asking if you're ready to go faster. But wait, I hear the purists screaming, it's too heavy! You're putting a boat anchor on the nose of a sports car. Look, I'll give you that. A dressed 460 weighs about 750 pounds. A modern aluminum LS or Coyote is around 450 to 500. On paper, that 250-pound difference is a death sentence for handling. But here's what most people don't realize. It's not just about how much weight you have. It's about where that weight is. A modern overhead cam engine is tall. It has massive cylinder heads filled with cams, chains, and phasers sitting high up in the engine bay. That raises the center of gravity. The 460? It's a pushrod engine. The heads are compact. The camshaft is buried deep in the block, just inches above the crankshaft. All that heavy iron is sitting low and centered in the chassis. Plus, and this is the kicker, the 460 makes so much torque, we're talking 600 pound-feet at 3,500 RPM, that you don't need short gearing. You can run a taller rear-end ratio. You don't need a heavy 6-speed transmission to keep it in the power band. A lighter 4-speed works just fine. By the time you factor in the lighter transmission and the lack of complex plumbing, the weight penalty isn't nearly what the forums say it is. This realization is what led to the rise of shops like Kuntz and Company in Arkansas. These guys aren't a massive factory operation. It's a 5-man crew. Shane Kuntz, the lead engineer, looked at the 460 and decided to apply modern material science to this ancient architecture. But he didn't try to reinvent the wheel, he just made it rounder. They started doing things that sounded insane. For example, using aluminum connecting rods in a street strip car. For decades, the rule of thumb was steel for street, aluminum for drag racing. Aluminum fatigues, it has a life cycle. But Kuntz realized that aluminum rods act like shock absorbers. In a big displacement engine with massive explosions happening in the cylinders, a steel rod transmits that shock straight to the bearing. An aluminum rod cushions it. It meant the bearings lasted 3 times longer. Sure, you have to replace the rods every couple of seasons, but for a weekend racer, that's a small price to pay for an engine that doesn't spin bearings. Then you have guys like Bob Schroeder at BS Racing Engines in Indiana. Bob is the kind of guy who tests engines by running them at full throttle for 24 hours straight. His philosophy is what he calls cockroach reliability. While the factory teams are measuring clearances to the 10,000ths of an inch, Bob runs his engines loose, like 1970s loose. If you heard one of his engines idling, you'd think it was broken. It rattles, it clatters. It sounds like a bag of hammers tumbling down a staircase. But as soon as that engine gets heat in it and spins up to 7,000 RPM, everything expands into perfect alignment. The oil flows freely, cooling the bearings. The slop disappears, replaced by a film of oil that acts as a hydraulic cushion. A Schroeder 460 went into a Corvette for the One Lap of America, an event where you drive 3,500 miles on the street and race on a different track every day for 8 days. The modern cars were dropping like flies. Electronics failed. Cooling systems burst. The rattly 460? The owner checked the oil once, added a quart, and finished the event without turning a wrench. Now let's talk money, because this is where the factories really hate this story. If you want to buy a competitive, road race-ready engine from Ford Performance or Chevy, you are looking at $25,000 to $35,000 easily. And that engine comes with a warning label that says, "No warranty if used for racing." The recipe for a 460 killer goes like this. You find a block in a junkyard for $300. You spend $1,500 on machining. You buy a top-tier forged rotating assembly for $2,500. You get a set of modern aluminum heads, which flow better out of the box than NASCAR heads did in the 90s, for $3,500. Throw in a cam and valve train and you are all in for about $12,000 to $15,000. You are building an engine that makes 750 horsepower, runs on pump gas, and costs half as much as the modern solution. You're not just beating them on the track, you're beating them at the bank. And for the privateer racer, the guy who's mortgaging his house to go racing, that is the difference between a dream and reality. But the story doesn't end with just finding old blocks, because eventually even the junkyards run dry. And this is where the industry started to shift in a way that nobody, not even Ford, saw coming. We are living through a gold rush, but instead of pickaxes and pans, guys are armed with sonic testers and flashlights, crawling through muddy scrapyards looking for D3VE casting numbers. See, Ford made millions of these engines, but they didn't make them all good. And as the secret of the 460 got out, the supply of the Holy Grail blocks, the early 1970s castings with the thickest iron, started to dry up faster than a puddle in the Sahara. 10 years ago, you couldn't give a 460 block away. Seriously, people used them as mooring anchors for boats. Today, a pristine standard bore block from 1970 can fetch $500 to $800 just for the bare iron. I've heard stories of builders driving 3 states over just because a guy on Facebook Marketplace listed a rusty Ford engine that looked promising in the photos. It's become an archaeological hunt. But here's where the ingenuity of the American mechanic really shines. When you can't find the perfect factory part, you don't give up, you improvise. And the hacks that these shop owners came up with to keep these engines alive are frankly terrifying to a modern engineer, but they work brilliantly. The craziest one, concrete. Yes, you heard me right. Concrete. It's a technique called hard blocking. The builders take a block that might have slightly thinner cylinder walls than they'd like, or one they plan to push to 900 horsepower, and they pour a specialized cement grout into the water jackets. They fill the engine block halfway up with rock. Now, you might be thinking, hold on, Legacy Motoring, isn't the water supposed to, cool the engine? Won't that thing melt? Here's the thing most people don't realize about internal combustion. The heat that kills an engine is in the cylinder head and the very top of the cylinder wall, the combustion chamber. That's where the fire is. The bottom half of the cylinder, that's just a guide for the piston. It doesn't get that hot. By filling the bottom half with concrete, you turn the cylinders into immovable pillars. They stop flexing. When the cylinders don't flex, the piston rings stay perfectly sealed against the wall. Better seal means more compression, which means more power. And because the water is still flowing freely around the top half of the cylinders and the heads, the engine temperature gauge doesn't even move. It's a trick from the drag strip that these mad scientists adapted for the street, and it makes these 50-year-old blocks stronger than a brand new race block from the factory. Then there's the diesel DNA they inject into these things. The builders realized that the stock cam bearings were a weak point if you started running massive spring pressures. So what did they do? Did they design a custom $500 bearing? No, they went to the parts catalog for a tractor. They found that cam bearings from certain industrial diesel engines were the exact same size, but made of much tougher material meant to last for 10,000 hours of plowing fields. They literally pressed tractor parts into a race car engine. It's hot rodding in its purest form, using what works, not what looks pretty. But the real Frankenstein moment, the thing that proves these guys aren't just living in the past, happened when a shop called Thunder Racing in Michigan decided to commit heresy. They asked, what if we took the best part of modern engines and forced it onto a 460? They were looking at variable valve timing, or VVT, in a modern car. In a modern car, VVT is used to make the engine sip gas at cruise and make power at redline. It's controlled by a computer the size of a shoebox. Thunder Racing figured out how to adapt a Toyota VVT to the cam gear of a Ford 460, but they didn't do it for emissions. They did it for violence. Imagine an engine that is physically locked into high torque mode on the starting line. The cam is advanced 20 degrees. You hit the gas, and it pulls like a freight train because the valves are opening early. Then, as the RPM climbs, a simple mechanism phases the cam back for top-end horsepower. No computer, no sensors, just mechanical logic. They took 1970s iron and gave it a superpower that Ford engineers in 1968 couldn't have even dreamed of. It's old iron with new tricks, and it terrifies the competition because it eliminates the one weakness of a big cam, the lack of low-man grunt. And let's talk about the fuel for a second. We all know that high compression equals power, but high compression usually requires race gas that costs $20 a gallon. The 460 builders looked at the diesel world again, specifically at Banks Power and the turbo diesel guys, and said, we want that. They started using water methanol injection. It's a simple system that sprays a mist of water and alcohol into the intake. It cools the air charge instantly and acts like chemical octane. This allows these guys to run compression ratios of 14:1 or even 15:1, numbers that are usually reserved for Formula One or pro stock dragsters, on 93 octane pump gas. The 460's bottom end is so robust it handles the cylinder pressure without breaking a sweat. So you have a guy filling up at the local Shell station, pouring a bottle of windshield washer fluid, which is mostly methanol, into a tank in the trunk, and then going out and outrunning a Porsche GT3. The pressure from these garage scientists became so intense that the aftermarket industry finally woke up. For years, companies like Dart Machinery or World Products ignored the 460. Why make parts for a dead engine? But when they saw the waiting lists at shops like Kuntz & Company, when they saw that people were hoarding rusty blocks like gold bars, they realized there was money on the table. Dart Machinery released a brand new aftermarket iron block based on the 460 architecture, but they didn't just copy it. They fixed a few gripes the builders had. They cast priority main oiling right into the block, so you don't have to modify it. They made the cylinder walls even thicker. They extended the cylinder barrels at the bottom so the piston is supported even at the very bottom of a 4.5-inch stroke. This was a pivotal moment. It legitimized the movement. It was the industry admitting, okay, you win. This architecture isn't dead. It's the future. Now, you don't have to scour a junkyard. If you have the cash, you can buy a better-than-stock 460 brand new. But, and this is a big but, the soul of this movement is still in the junk. There is a specific pride in taking the trash block, the one nobody wanted, filling it with concrete, stuffing it with aluminum rods, and beating the guy who wrote a check for the Dart block. It's creating a divide in the community. A civil war between the junkyard dogs and the checkbook racers. But both sides agree on one thing. The 460 is the king. And this dominance isn't staying local anymore. You might think this is just an American phenomenon, a bunch of rednecks in the Midwest playing with old V8s. But you'd be wrong. The infection is spreading. The engine Ford forgot has crossed the ocean, and what it's doing in Europe and Australia is even crazier than what's happening here. We tend to think of the big block Ford as purely American hardware, as American as a cheeseburger and just as heavy. But physics is a universal language, and speed translates into every dialect. The 460 has gone global, and in doing so, it has created some of the strangest, most wonderful cultural collisions in automotive history. Take Australia. The Aussies are just like us, only crazier and with better roads. They have a massive, historic touring car scene. These guys take old Ford Falcons and Holden Commodores and race them around terrifying tracks like Mount Panorama, a circuit that is basically a mountain road with no guardrails and a concrete wall waiting to high-five you. For years, the Ford guys down under struggled to keep their smaller displacement engines together on the long uphill straights. They needed torque. They needed durability. So they started looking north. They started importing these Kuntz & Company and Kase-style engines from the States. Suddenly, you had Australian race teams, who usually pride themselves on homegrown engineering, bolting in American iron. The result? They started pulling gaps on the Holdens that looked like glitches in the timing software. The 460's ability to sit at 6,500 RPM for long periods without vibrating apart was perfect for the endurance nature of their racing. It was a trans-Pacific alliance forged in cast iron. But the real shock comes from Europe, specifically Germany. This is the land of precision, the land of Porsche and BMW, where engineers wear lab coats and measure things in microns. Yet there is a growing underground subculture of German tuners who are fed up with the complexity of modern European engines. They are tired of Vano systems failing, of timing chains that are located at the back of the engine requiring a complete cab-off repair. So what are they doing? They're taking old Mercedes sedans, the big boxy ones from the 80s, and swapping in 460s. I saw a video recently of a matte black Mercedes drifting the Nürburgring, that famous green hell track. It didn't sound like a Mercedes. It sounded like NASCAR, and it was passing dedicated track cars like they were standing still. The German engineers watching from the sidelines must have been having an aneurysm. Here was this crude, pushrod American lump built with sloppy tolerances, outlasting their high-strung masterpieces. It's the ultimate insult, and honestly, it's beautiful to watch. This brings us back to that David versus Goliath dynamic I mentioned earlier. It's one thing to talk about specs, it's another to see it happen in the heat of battle. And there is one story that, for me, perfectly encapsulates why this engine is legendary. It involves a guy named Bob, just a regular guy, not a pro racer, and his C4 Corvette. Now, the C4 Corvette is a decent car, but in the world of high-end time attack racing, it's a dinosaur. Bob decided to run the one lap of America. This is a grueling event. It's basically the Cannonball Run meets the 24 hours of Le Mans. You drive thousands of miles on the highway, sleeping in motels, and every morning you wake up at a new racetrack, race for time, and then get back on the highway. The field was stacked. You had factory-backed Porsches. You had Nissan GTRs with $50,000 engine builds. You had the latest Chevy Corvettes with their fancy LS7 engines, titanium rods, dry sump oiling, the works. And then you had Bob. Bob had swapped the junkyard source Schroeder-built 460 big block into his C4. It barely fit. He had to cut a hole in the hood so big it looked like the engine was trying to escape. On day one, the snickering started. Look at that redneck engineering. Look at that redneck engineering. That thing will overheat before lunch. It's too heavy for the corners. The first track was wet, slick. The high-tech cars with their traction control systems were struggling to find grip. Bob, he just lugged that 460 around in third gear. The torque curve is so flat and so wide that he didn't need to shift. He didn't need to shock the tires. He just rode a wave of torque from corner to corner. He put down a time that was top 5 overall. The snickering turned to confused whispering. Day 3. A high-speed track. The modern engines were screaming at 8,000 RPM to make power. Heat was becoming an issue. We saw a $100,000 Nissan GTR pull into the pits with steam pouring out of the hood. A modern Corvette dropped a valve because of an oil starvation issue in a long sweeper. Bob's 460? It was running at 180 degrees. The oil pressure gauge was glued to 60 psi. He wasn't even stressing the engine. He was shifting at 6,000 RPM, letting the massive displacement do the work. By day 8, the field of cars had thinned out. The fragile high-tech machines had succumbed to the abuse. Bob finished the event. He didn't just finish, he placed in a position that embarrassed teams who had spent more on their tires than Bob spent on his entire car. He drove 3,500 miles, raced 8 tracks, and the only maintenance he did was check the dipstick and clean the bugs off the windshield. That story circulated through the pits like a ghost story. It forced people to ask a question that makes marketing departments very uncomfortable. Did we actually go backwards? We are told that progress is a straight line, that 2026 is better than 2016, which is better than 1968. But is it? Or did we just trade durability for complexity? Did we trade longevity for efficiency? The 460 proves that sometimes the old way wasn't just a result of primitive technology, it was a philosophy. It was a philosophy that said, build it tough first, worry about everything else second. The engineers who designed this engine had lived through wars. They understood that things break and that the best way to prevent things from breaking is to make them twice as big as they need to be. Modern engines are miracles of optimization. A new 5.0-liter Coyote is a masterpiece. It makes 480 horsepower, gets 25 mpg, and passes emissions that would make a 1970s engineer faint. It is better by every objective metric we use today, except the one that matters when the chips are down. Can you beat on it with a sledgehammer and expect it to wake up tomorrow morning? The 460 is the sledgehammer, and what we are seeing now is a cultural pivot. A generation of enthusiasts who grew up on iPhones and software updates are realizing that there is something deeply satisfying about mechanical simplicity. They are realizing that they don't want to be locked out of their own engine bays by proprietary software. They want to be able to fix it with a wrench. This is why you see 20-year-old kids who weren't even born when the 460 was discontinued hunting for these engines. They are rejecting the disposable culture of modern tech. They don't want an engine that is designed to last 100,000 miles and then be thrown away. They want the forever engine, and they're finding it in the rust piles of America. But this revival has a deadline. As I mentioned, the blocks are getting scarce. The easy finds are gone, and this scarcity is forcing the movement to evolve once again. We are entering the final phase of the 460 story, the transition from junkyard hero to boutique legend. And frankly, what is happening now in the high-end custom shops is even more impressive than the racing stories. They're taking this tractor engine and turning it into something that rivals the finest Italian exotics, not just in power, but in beauty. The world of high-performance engine building is usually a dirty business. It's oil stains, metal shavings, and shop rags. But if you walk into one of the elite shops today, the ones that have taken the 460 architecture to its absolute limit, it feels less like a garage and more like an operating room. The transition from junkyard dog to boutique legend is complete. And the results are rolling pieces of industrial art that just happen to produce 1,000 horsepower naturally aspirated. This is the final evolution of the 460 story. We aren't just talking about racers anymore. We're talking about the checkbook hot rodders, the guys who want something unique in their million-dollar custom builds. They are tired of the LS swap. Everyone has an LS. It's boring. It's the Toyota Camry of engine swaps. But popping the hood to reveal a massive, wide-shouldered Ford big block, that makes a statement. Shops like John Case Racing Engines have tapped into this. They aren't just rebuilding engines, they are re-engineering history. They offer the Boss 9 conversion, which takes a standard 460 block and fits it with massive semi-Hemi heads that mimic the legendary Boss 429. These engines are jewelry. They are polished, painted, and perfected to a level that Bill Gay and the original 1968 engineering team couldn't have imagined. And the price tag? You're looking at $60,000 or more. It sounds insane, 60 grand for an engine design that is eligible for AARP benefits, but the people buying them understand something that the spreadsheet-obsessed executives in Detroit forgot. Emotion matters. Character matters. A modern engine is a tool. It does a job efficiently. A 460 is an experience. It vibrates your chest. It smells like gasoline and nostalgia. It connects you to the machine in a way that a sanitized fly-by-wire electric motor never will. And here is the ultimate vindication. The final proof that the David in our story, the small shops, the rednecks, the garage scientists, didn't just outsmart the factory teams, they actually changed the factory's mind. In 2020, Ford released a new heavy-duty truck engine. For decades, the industry trend had been smaller displacement, overhead cams, and turbochargers. Everyone expected a twin-turbo V6 or a hybrid setup. Instead, Ford dropped a bomb, the 7.3-liter Godzilla. Look at the specs of the Godzilla. It's a pushrod V8. It has a cast iron block. It has massive displacement. It has a bore spacing that is suspiciously similar to the old 385 series. It uses simple, robust architecture. Ford will never admit this in a press release. They will never stand up and say, yeah, we watched what the privateers were doing with the 460 and realized we were wrong. But the Godzilla is a love letter to the 460. It is a factory-built admission that for certain applications, for hard work, for towing, for racing, for longevity, complexity is a liability. Simplicity is the ultimate sophistication. The engineers at Ford Performance looked at the success of the aftermarket 460 blocks. They looked at the racing wins. They saw that people were willing to pay a premium for dumb iron that didn't break. So they built a modern version of it. The Godzilla is essentially a 460 that went to college. It has better flow and modern sensors, but the soul? The soul is pure 1968. This is the legacy of the 460 revival. It didn't just save a few old Mustangs from the crusher. It forced a billion-dollar corporation to hit the reset button on their engineering philosophy. It proved that sometimes the old guys in the dusty shops actually know more than the supercomputers. So where does that leave us? We are standing at a crossroads in automotive history. On one side, we have the future the industry wants to sell us: silent, autonomous, disposable, and subscription-based. On the other side, we have the 460, loud, mechanical, repairable, and eternal. The shops building these engines, Kuntz, Kaz, and Schroeder, and the hundreds of nameless builders in garages across America are doing more than just making horsepower. They are preserving a way of life. They are keeping the flame alive for the idea that a human being should be able to understand the machine they drive. They are proving that you don't need a degree in software engineering to go fast. You just need a socket set, a torque wrench, and the courage to ignore the experts who tell you that your engine is obsolete. There is a beautiful irony in all of this. The engine that Ford tried to kill in 1982 is now, in 2026, the hottest ticket in town. The trash became the treasure. The boat anchor became the champion. And every time a 460-powered Mustang roars past a silent, sterile electric car on a track day, it's not just a pass. It's a protest. It's a middle finger to the idea that we have to accept a future where we are just passengers in our own machines. As I write this, there is probably a kid in a driveway somewhere, covered in grease, looking at a rusty 460 block he just dragged home. He's reading forums. He's watching videos. He's dreaming of 800 horsepower. He doesn't know it yet, but he is part of a revolution. He is the next guardian of the flame. And as long as there are people like him, and people like you watching this, the spirit of the 460 will never die. It turns out that in the race between the tortoise and the hare, the tortoise didn't just win. The tortoise built a 598 cubic inch big block, strapped a turbo to it, and blew the hare's doors off. This is the real story here. Not just that old engines can beat new ones, but that knowledge, experience, and understanding fundamental engineering principles will always beat throwing technology at a problem. These small shops didn't outsmart the factories. They just remembered what the factories forgot, that sometimes the old ways worked for reasons we're only now rediscovering. What's the most unlikely racing success story you've ever witnessed? Drop a comment below and share your David versus Goliath moment. And if you enjoyed this deep dive into the world of forgotten performance and the engines that refuse to die, make sure to hit that subscribe button because we are just scratching the surface of abandoned technology that is secretly superior. Until next time, keep those engines turning, especially if they're older than you are.